Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 4, Section 7, Scientific Notation. Before I begin, I want to make it clear that scientific notation is an approximate way to represent a bigger number. You don't necessarily recreate the bigger number, but you approximately recreate it. It's an abbreviated or shorter way to write bigger numbers, but you're not writing them exact. So, for example, if I were to write 1,236,000, okay, in scientific notation, I would write that as 1.23 times 10 to the 6th power, which if you write 1.23 times 10 to the 6th power out, what happens is, since we're multiplying by 10 to the 6th power, that actually moves the decimal over 6 spaces to the right. Okay, 1, 2, 3, 4, 5, 6 spaces to the right. All those blanks get filled with zeros. And so we actually end up with 1,230,000. Typically, when you're writing scientific notation, we don't write more than 2 decimal places over. And I'll talk a little bit more about that here in just a moment. So there's 3 things we're going to talk about when it comes to scientific notation over the next 2 videos. We're going to talk about how to write scientific notation of whole numbers, how to write scientific notation of decimals, so numbers less than 1, and how to write and how to multiply with scientific notation. But the first thing we're going to look at, though, to make sure we understand what's happening with scientific notation, are the powers of 10 that you saw earlier. If you take a look at the powers of 10, they have a special property about them. Okay, so 10 to the first is equal to 10, and what's special about multiplying by just 10 is it actually just moves the decimal place over once. So this is going to move to the right, okay, 1 space. 10 to the second power is actually 100. So 2 zeros, second power, 2 zeros. And that's going to move you 2 spaces. Okay. 10 to the third power is 1,000. 3 third power, 1,000 moves you 3 spaces. So 10 to the third power has 3 zeros, moves you 3 spaces. 10 to the fourth power, if you can guess, has 4 zeros and moves you 4 spaces. So for example, if I had the number 12.6 and I multiplied it by 10, it would become 126 because I'd move that decimal over 1 space. If I multiplied 12.6 times 10 to the second power, it'd move that decimal over 2 spaces. The blank is filled with a 0. So I would get 1,260. And that pattern just keeps continuing on and on and on. So that, as long as you understand that concept, scientific notation should be pretty simple. So if we start with a number like 964, okay? The decimal in a number, when you don't see the decimal number, the decimal's at the end. So what we're going to do is we're going to take this decimal and we're going to move it back between the first and second number. Then we're going to write 9.64. We're going to multiply that by 10 to the second power because we move the decimal back 2 places. So when we take this new decimal that we have, this 9.64, we want to make sure when whatever we multiply it by moves that decimal back to where it was, to the right, 2 spaces. So the decimal's here now. If you look down here, the decimal's now here. I want to move it back to where it was originally, which is over here. So I need to move it to the right 2 spaces. So I'm going to take this decimal and multiply it by 10 to the second power. So that decimal, when I multiply it, will move 2 spaces over, and I'll get 964. With the smaller numbers, it's easy to make scientific notation represent the exact number like we did here. This scientific notation, okay, got me exactly 964 like we had up top. But if you do bigger numbers, which is where scientific notation is used more often. It's not very often you see scientific notation used with smaller numbers in the hundreds. But if you use it with bigger numbers, such as, we'll go with 1,236,523. Now, I'm not going to write a decimal of 1.236523. Okay, it kind of destroys the purpose of scientific notation, which is to find an abbreviated or shorter way to write this. Okay, so what I'm going to do is I'm going to move that decimal back 1, 2, 3, 4, 5, 6 spaces, so it's between the first and second number. I'm going to write 1.23. Okay, I'm never going to go more than 2 spaces over. So I'm going to write 1.23 times, and since I moved back 6 spaces, I'm going to write times 10 to the 6th power. Because 10 to the 6th power, when multiplied by 1.23, will move that decimal back to the right 6 spaces, so it ends up where it started. So if I were to write this out in what's called expanded form, I would take the 1.23, move that decimal 6 spaces, fill the blanks with zeros, and I would get 1,230,000. Okay? So this is what I was talking about when I said that scientific notation is an approximate way to abbreviate something. You're not typically getting the exact number you had before, but you're getting something that's really close. It's really good. It's really good when you need to estimate. When you need to estimate products and such with using scientific notation is good when you need to estimate large products. And you don't want to write out these large numbers and do all this math that would take you probably anywhere from 5 to 6 minutes. Even if you're fluent at math, sometimes these larger numbers, if you try multiplying them out normally, will take several minutes just because of the amount of work it takes to finish the multiplication. So scientific notation helps to quicken that process and get you an answer that's relatively close to what it should be. So I'm going to do one more example. Let's say we had the number 572.46. Okay, again, decimal is going to go back between the first and second number. I'm going to write 5.72. Okay, never go more than 2 spaces over. And I'm going to do times 10 to the 2nd power because I moved my decimal back 2 places. And so if I wrote this out in expanded form, it would be 572 because 10 to the 2nd power would move that decimal over twice. I would have 572. Okay. So at this point, I would like to take a moment and talk about how to do scientific notation when you have a number less than 1. Okay, so for example, when you have a decimal, such as this, and you want to write this in scientific notation, this can be done as well. What we're gonna do is we're gonna move this decimal so it's between the first and second number, not counting zeros. We're not gonna count zeros as numbers. So we're gonna move this decimal 1, 2, 3 places because 2 and 4 are the first and second numbers that appear in this decimal. And so we're then gonna write 2.46 times 10 to the negative 3. Because this time, before, we were moving our decimal back, so when we multiplied, we wanted our decimal to move to the right. Well, this time we're moving our decimal forward, and now when we multiply, I want this decimal to move left. So when you multiply something by 10 to the negative power, it does the opposite of what something times 10 to a positive power would do. A positive power will move you to the right. 10 times a negative power will move you to the left. Blank spaces are filled with zeros. Decimals move to the end. I now have 0.00246, just like I had up here. Okay, so I'm going to do that one more time. I'm going to do another example, just to show you how it works. Okay, I've got, let's say, 0.01489. Okay, I'm going to move that decimal forward. Okay, so it's between the first and second number. So in this case, we have 1.48 times 10 to the -2 because I moved it forward 2 spaces. So when I multiply it out, I want to make sure it moves back 2 spaces to where it was. So to move back 2 spaces, we use negative exponents. So at this point, if I was told to write this in expanded form, okay, I would take my 1.48, I would move it back 2 spaces. Blank space is filled with a 0, and now 0.0148. Now this is not the exact number I had before, but again, scientific notation is an approximation. So this is not the exact number I had before, but it's very close. It's very similar. I have 0.01480 instead of 0.01489. Now I can add that. I can add as many zeros as I want on either of these numbers, just so you know. Anytime a number looks like it has stopped, there's a bunch of zeros that go on forever. We just typically don't write them because they don't stop. They are infinite. So you could never stop writing them, technically. So that's how you take decimals and whole numbers and write them in scientific notation, and then take the scientific notation and write it in expanded form. So hopefully you took good notes on how that works. And the next video will be on how to multiply with scientific notation.